Okay, recording for Cole, if he doesn't come back pretty soon, and Emma. We are starting to actually solve stuff. I'm so excited. No more of this, like, make the equation. They're going to give it to us and say, find the answer, right? That's the fun part. That's the fun part. Solving, but these only involve one step, and then you're done. It's like, do one thing, you find the answer. Do one thing, you find the answer. In the next section, we have 2 steps, right? Okay? And then they add a little bit more to that in section 4, okay? But today, 1 step, all right? Now, here's the deal. They have what's called the addition property of equality. Let me write an example off to the side over here. Let's say that I have x minus 4 is equal to 2, okay? And I want to solve for x. X is subtracting 4, and if I want to get the 4 to the other side, I have to do the opposite of that, right? Which is add the 4. And because of the addition property of equality, it says that as long as I do it to both sides of the equal sign, it's legal. Right? So I would do that. The 4 would cancel out on the left side, and I would have x equals 6, and that's the answer. I'm adding the same number to both sides, because if you add it to one side, you have to add it to the other side in order to stay balanced, right? Okay? All right, so let's go down to the subtraction property. So let's say I have x. Let's do a hard one. Let's say x plus, let's say x plus 1/4 is equal to 3/4. Okay? Nope. Okay. So in order to get the x by itself, the x is adding 1/4, so I have to do the opposite, which is subtract 1/4, right? Because they have a common denominator, I'm taking 3/4 minus 1/4, which is 2/4, right? But what's 2/4 reduced to? 1/2, right? They have to have a common denominator. Good, good? Okay. So they want us to solve by adding. Use the addition property to solve. So we have this guy. And G is subtracting 25. So I have to do the opposite of that, which is add 25. So I'm going to add the 25 here. Add the 25. It is super helpful to write it right below if you can, because then I cancel, right? So I don't know if you guys are used to doing this, but like if I write 25, negative 25 and positive 25, they cancel each other, right? So then all I have left on this side is G equals, and if I put those two together, that's 138.
It looks like you're dividing by 25 with the line.
I know it does. I know it does. I shouldn't put that line in there. There you go. So I just add the 25 right below, and it cancels it out, right? So G is the only thing left. Got it? Okay. Let's do example 2. Solve by subtracting. Okay, this time they put the 27 first. Okay, so if I want to get K by itself, how do I get rid of 27?
You subtract 27.
How do you know you have to subtract 27?
Because there's no
The 27 is positive, right? So I need to subtract 27. That cancels it here. And K equals 3. Okay, good.
Is this all we're doing today?
All right, that's all we're doing today. Hold on. We got to do multiplication. Write a one-step equation and then solve it. So in tennis, the Grand Slam tournaments are the 4 most prestigious annual events. At one point in his career, Roger Federer won 3 more Grand Slam single titles than Rafael Nadal. So 3 times more. Roger Federer, I'll say R, I'll call him R, won 3 more, not 3 times more, just 3 more than Rafael Nadal. So I'll say, let me call him F, Federer and Nadal, because they both start with R. And N, yep. So I have to take Nadal's score plus 3 to get what Federer's was, right? Because that would end up making this more, okay? Let's see, and then they're giving me a number. If at that time Roger Federer held a record, and he had 17, how many did Nadal have? So where are we plugging 17 in?
R.
F, right? 17 equals N plus 3. Now to get the N by itself, I'm going to subtract the 3.
14.
And N is equal to 14. So Nadal at that time had 14. Perfect, perfect. Not too bad. Easy. Easy peasy. Okay? Grand Slam single titles. Wow. Okay, we got to do multiplication division. So one more. Go to the next page, and we have the multiplication property of equality. So let me give you an example. Let's say, we'll use their example. 8x equals, no, wrong. Let's do this. Let's say x over 2 equals 6. Okay, now here's my question. What is x doing to the 2?
Dividing.
It is dividing
So we
2, right?
multiply by
So
2.
to get rid of it, I have to do the opposite, which is multiply by 2. That cancels him here. But what I do to one side, I have to do to the other because it's the multiplication property of equality, right? So x is equal to 12. Every time you do this, you're going to say, okay, what is being done? Do the opposite. The opposite of add is subtract. The opposite of multiply is divide, and that type of thing, okay? So you're going back and forth, okay? Same thing here, division properties. So let's say they have 8x equals 24. 8 and x are being multiplied. So we have to do the opposite, which is divide. And the 8 and the x are going to cancel, and x is equal to 3. And because of the division property of equality, it says as long as I do it to both sides, it's legal, right? Easy peasy. Okay? All right, let's do this one. Whoa! An everything property of equality. I know. All right, this one's hard. Ooh. This one's hard. 3/8 and x are being multiplied together, right? So I want to divide by 3/8. Now here's the problem. If I divide by 3/8 and divide by 3/8, if I'm taking a fraction, that cancels out on that side, right? If I take 9/4 and divide by 3/8, have you guys heard of keep, flip, flip before? So I'm going to keep the 9/4, but I'm going to flip my division to multiplication, and I'm going to flip 3/8 to 8/3. Okay, now we're going to do math first before we find the answer. 9 and 3 will reduce to 3 and 1, right? What about 4 and 8? 1 and 2, right?
Yeah.
So now I multiply across. So this is 6/1 or just 6, okay? So when you are dividing by a fraction, you multiply by the reciprocal, right? You keep, flip, flip. Do we know that?
Yeah.
Yes? Okay. Let's do the next one. Ooh. Now I want to get y by itself. The y and the 14 are being multiplied, right? So I'm going to divide, but what are you dividing by?
-14.
The negative and the 14 go together. So you're dividing by -14. So y is left here. What's 42 divided by -14? 3. -3. The negative goes with the 14. Do we see how that works? Okay, I have a lot of people. Look at this problem. I have a lot of people that look at this and they say, I'm going to add the 14 to the other side. Because they see that negative. But what's the 14 and the y doing? Multiply. So you have to divide. So be careful. Be thinking. All right? Don't just add the 14 over. You're going to divide by -14. Good? Okay, let's see what else we got. Solve by multiplying. Kenji took a survey of the sophomore class. If 96 sophomores, or 2/3 of the class, said they were going to the football game on Saturday, how many sophomores were in the survey? Okay? So 96 is equal to 2/3 of the class. 2/3, what's the word of mean?
Equals.
Multiply. Of the class means, I'm going to say n. Times n. Of means multiply. 2/3 of, or times the number of the class, right? Okay? So there's that, and I want to find n, right? So I'm going to divide by 2/3, but dividing by 2/3 is the same thing as multiplying by 3/2, right? Okay? So let's figure out, how do we take 3/2 times 96? I'm going to put 96/1. Now I can reduce. The 2 and the 96 can become 1 and 48. 48. So 3 times 48 is 144. What did you say? 144 is final answer. So there's 144 kids in that class. 2/3 of that would have been 96. Easy peasy, right? Okay. Do we know what we're doing? We're okay? Was that it? That's it. Holy moly. All right. 14 problems. Most of them are one step. Can I what? Oh, yeah. By fours. So you don't mix them up. 4 and 8 and 12. It's kind of in a diagonal. And then 16 and 20 and 24. That's another kind of a diagonal. Then 28, 32, 36 is a diagonal. 40, 44, 48 is a diagonal. 40 looks hard. Then 52. Should we look at 4? Oh, and then 56 on the backside. They're all like diagonals. Shall we look at number 40 together? Let's do it. I don't like that double bracket. Or that double, like, parenthesis there.
I don't like it.
Ugh.
So that's just 74, right?
Nope.
Isn't that?
This is x minus 74.
But it's negative 1 times negative 74, so it just turns into 74.
I like
So
it.
that'd be
I like it. Let's do that.
74x.
Two negatives make a
Positive.
positive. So this really, if I rewrite it, is x plus 74.
Isn't
And that's
it
equal to
times?
negative 22. Nope. Nope, because it's a minus right
There are
here.
2 terms.
Yep. They're two separate pieces. Yeah. Yeah. Okay. So now it looks like this, right? Two negatives make a positive. So it's plus 74. Now I want to get x by itself. So I'm going to subtract the 74. He is gone now. So x equals negative 96. Is he right? I think so. Okay. Now, if you want to check your answer, you can always plug it back in to see if it comes out right. Okay? Good, good? If you want to do a couple and then check with me, you sure can. That's fine. Okay?
Can you do number 8 with this?
8. Oh, that's another one. Woo.
Yikes.
Okay? All right, here we go. Two negatives make a
So that'd be negative
positive. So I'm going to rewrite it as negative 16 plus t equals negative 45. All right, I want to get the t by itself. How do I get rid of the 16? Yeah, I'm going to add 16 because the 16 is negative, and that's going to cancel them out here. Add 16. So all I have left is t. What's negative 45 plus 16?
29.
Negative 29? Negative 29, you betcha.
Can you go over number 12? I don't understand how you get the fraction.
Ooh. Okay, all right, here we go.
Wait, so you would
Just ignore this negative for now. What's the k doing to the 5?
divide.
Dividing by 5. So I want to multiply by 5, but
Negative.
I want to multiply by negative 5. So I'm timesing by negative 5. But what's 5 as a fraction? 5 over 1. So I can reduce this 5 into 5. 1 and negative 1, right? So 7 times a negative 1 is negative 7. You betcha.
Negative 7.
Yep, yep.
I don't like fractions.
They're kind of ugly. Okay, how about that? All right, I will stop recording for Cole and Emma. Goodbye.